let's try this. Actually, it works. When people stop talking when I start talking, it's amazing. Okay, welcome. I was a little worried that this wouldn't work because I'm presenting from my phone, but usually it works, so, we're good. Welcome to Vox Day, Zurich. I'm very happy to be here. My name is Chris. I work for, exactly, Twitter. So, the first and most important question of the day is, the lights are a little, but who in this room has a Twitter account? Ooh, I love Switzerland. So much better than India or Eastern Europe. They all use Facebook. I don't know. It's so weird. So you should tweet about this event. I hope you had some good sessions today already. Tweet about them if you like them so that other people know how cool it was. I think all of these are recorded and then they can watch it later on YouTube, I'm assuming. If you're going to tweet about my talk at this hashtag, Twitter has a not so small anymore VM team. We used to be only 4 people, but we grew in size. We doubled. We are now 8. And we have about 3 GC engineers who are constantly busy. Everyone has GC issues, so they're constantly busy doing that stuff. I'm a compiler guy, so I do the fun stuff, including going here and telling you about the cool shit we're doing. Then we have someone working on Graal optimization specifically for Scala. Then we have someone working on autotune. This talk will be about autotune. And so we do a bunch of things. So add this hashtag that my people know that I was actually here and not skiing in the Alps. So a little bit about me. If you don't know me, as I said, my name is Chris. I worked on JVMs for a very long time, over 14 years now, and all of these 14 years, basically, I was working on JIT compilers. So I'll ask you a bunch of questions during my talk. Who knows what a JIT compiler is? Hey, it's amazing. I don't have to explain anything here. So, yeah, you know what C1 and C2 are? Okay, well, we'll explain that a little bit. So at Sun, I worked for Sun and Oracle, and I always worked in the Hotspot compiler team. And in the Hotspot compiler team, I was mostly working on C2. So everyone knows what Hotspot is. Yes, Hotspot is the JVM of OpenJDK. And Hotspot has, today, 2 JIT compilers, right? One is called C1, or client compiler, and the other one is called C2, or server compiler. You might have heard client and server before, right? Maybe not C1 and C2. So C1 is a high throughput compiler. It compiles code quickly, but it doesn't do a lot of optimizations. The purpose of C1 is to get away from interpreting code as quickly as we can, right? Interpretation is slow. We want to run on native code. That's C1. And then, next question before I go to C2, who knows what tiered compilation is? All right, okay. So tiered compilation, when you run something in Hotspot or IBM's J9, they do something similar. You start out interpreting your code. So Hotspot has 4 tiers. 5-ish, but actually 4, because the tier 0 is interpretation. We're not really counting that. So there are 4 tier levels, and 1, 2, 3 are C1 levels, and they have different amount of profiling data they collect. And then tier 4 is when you recompile with the profiling data you collected with C2. So you're stepping through tiers to end up at your peak performance code, right? And so we have C1 and C2 is a peak performance compiler. It does a lot of optimizations, escape analysis, loop unrolling, auto vectorization, and all that stuff. So I was working on C2. Then these are the 3 biggest projects that I worked on at Sun and Oracle. JSR292, Invoke Dynamics. Some people might know it. Method handles. Maybe you use it. There were 2 implementations. The first one was a lot of handwritten assembly code in the JVM. That was a lot of pain, especially to port it, and then we had a performance issue, so we had to rewrite the whole thing, and we moved a lot of that logic into Java, into a package called Java Lang Invoke. And I wrote a lot of that core library code, to be honest, so if it doesn't work, you could technically blame me. But, as I always like to say, my code was perfectly fine, and the people who touched it after me, they broke it. So then we did CHEP 243, in JDK9 Java level JVM compiler interface, JVM CI. We basically took the interface that Graal used, extracted it, and made it a API. It's not really a supported API, but it's kind of stable-ish. So we have an API that you can plug in an external JIT compiler. Today, there's only one that uses this interface, and that's Graal, but there could be more. If you want to write a JIT compiler, easy. We have an interface for it. Then we integrated JVM CI for JEP295, which we also did in JDK9 ahead of time compilation. This is not native image. Right? This is not a native image, it's not substrate VM. It's something different. It's a command line utility that takes in Java class files and then sends it off to Graal. It compiles it, and then it spits out a shared library at the other end. And Hotspot can pick up that shared library. Sometimes it helps for startup performance. So if you have some startup issues, a big app or something, you could try this. And now I work at Twitter. It's an amazing company. I love it. It's great. This is what Twitter looks like. Lots of services, lots of instances. We have hundreds of services and thousands of instances of these, and we run on heterogeneous hardware like pretty much everyone does. So the problem is performance optimization, right? So hand tuning doesn't scale. We've all tried that. At your job or whatever you're doing, at some point, you probably got upset with the situation as it is, and then you tuned it a little bit, and then you forgot about it. And then in 3 years, you're coming back and you're upset again. So it's kind of that 3, 4, 5 year cycle that you do a little bit of optimizations, but you can only do a few parameters manually, right? I mean, you have to build up a model in your head, and it's very time consuming and labor intense, obviously, and error prone, and upgrades. Like we all live kind of in a microservice world, like Twitter, microservices. You saw the graph, thousands of them. Some of them we deploy multiple times a week. We're not the multiple times a day people, but that's what people do these days. And that means that upgrades, basically you lose the optimality that you just tuned. So, very important, many services operate below optimality, and it's certainly true for Twitter. And it's 100% true for your stuff as well. So what we really want is something that tunes this stuff for us. So I have a little bit of theory here to talk about performance tuning, what it is. It's basically you have a function over a domain X, and then you want to find a configuration to maximize F, whatever that F is, right? Could be performance or CPU utilization or memory consumption, I don't know. You want to do something with it, and it's always subject to a constraint, right? The constraint basically, and you'll see that later in all of my graphs and experiments, the main constraint is it still has to work. Because you will see that also, you can tune it too far, and then it's not working anymore. Either it doesn't come up, or it's too slow, latency, blah, blah, blah. So performance tuning in general looks like this, right? So you pick a parameter, you run it, you measure it, and then you get something back, a performance number, whatever it is, and then a person decides if that's good or not. And the person needs then to decide what to try next to make it better. So we want to replace that person with something. Black box. I don't care. I really don't. Doesn't matter. I don't want to do it. It should be a machine. So optimization of a black box function. So we use something called Bayesian optimization. And it's a method to learn potentially noisy objective functions, blah, blah, blah. Iteratively, efficiently. That's very important. Because we want to do it iteratively, right? And we want a result quickly. Finds new optimal in few iterations. That's what we want. We can't tune forever, because in the meantime, the code already changes. So we need a result quickly. Works well with nonlinear, multimodal, high-dimensional functions. Very important. The JVM has hundreds of parameters you could tune, right? If you only tune one, right, you could do it manually too, but we want to tune many at the same time to get a performance improvement. The theory behind Bayesian optimization and how it works, I really don't know it that well, but Ramke does. So he's my colleague at Twitter. There are 2 presentations he gave. If you're really interested in that stuff, listen to this. He explains it really well. If you look at these slides that he has, I stole them. And so I'm trying to explain to you very basically now how Bayesian optimization works, so we'll understand a little bit better the graphs that I'm showing you later. All right, so we have one parameter that goes from -6 to 6, and then performance, highest, better. We did 3 evaluations that are actually real results that we got by running an evaluation. And this graph is the actual performance curve, which we don't know, right? So what Bayesian optimization does, it assumes a curve, and the blue area above the graph, the curve, is basically the certainty it has, the Bayesian optimization part. If we find a better performance here or not, so overlaid with the actual one, it looks like this. And then what you do is you put in a line like this with your best result, and then at the bottom you get something called expected improvement. The red graph is basically the area of blue above the red line, right? If it's more, it's very likely they'll find a better result. So that's what it's doing. So we take the biggest one down at the bottom. We try that one, see, it was a little bit better. We try the next one in the middle, cool. Then the one on the left, looks like this, better. Then this one, perfect. Then we exhausted that area, right? And then we go back, I think, on the left now, if I remember correctly. No, over there, like that was worse. Then way on the left, also not as good. And then we exhaust that space, and then we try this one, this one, this one, and we find the optimum. That's basically how Bayesian optimization works. And that's what we're using. You pass in a parameter, it tries, through the whole space it has, and then it tells you what the result is. So we like it. It's parametric, robust, extensible, battle-tested on many types of real-world high-impact problems. We really, at this point, we are not there yet, but what we really want with this tool is to have it on in production all the time. We want the system, all of our services, to tune themselves individually all the time. That would be cool. We're not there yet, but we want to do it. Good. So that was kind of the theory part that I really don't know that well, but I think you get a rough understanding of how it works. This, I know better. Experiments. All right. So what is AutoTune? I call it a BOAS. It's Bayesian Optimization as a Service. It's really a service that runs inside of Twitter. And then there's this thing called, oh yes, I should explain this. So we bought a company at some point. It's called WetLab. And that's an enhancement of a framework called Spearmint. So WetLab, unfortunately, is not open source, and we probably can't open source it. But Spearmint is. And it's not as good as WetLab, but you could still use it to do something what we're doing. And then we have AutoTune, which is just a driver to run experiments. So we run at Twitter on Mesos in Aurora. And our implementation, basically it's a backend, right? You start jobs, have them running for a while, you kill them, look at the performance numbers. That's what AutoTune does. And then AutoTune, you tell AutoTune which parameters to tune. It runs the evaluations. And then it talks to the BOAS, the Bayesian optimization part, which value of the parameters to try next. That's the thing we just saw earlier, right? Make sense? Okay, it's not that hard. What is Graal? Do people know what Graal is? It's Zurich, everyone should know, right? They're sitting right over there in the glass tower. So we know what a JIT compiler is, so Graal is a JIT compiler. I'm not talking, by the way, about Graal VM. So Graal VM is something different. It's not well-chosen marketing name, as I'd like to say, and basically an umbrella name for 3 different technologies. It's Graal, the JIT compiler, that's the one I'm talking about, Truffle, and Substrate VM. And you might know Substrate VM better under the name Native Image. So I'm only talking about the JIT compiler, nothing else. And we use nothing else at Twitter at this point in time. Okay, so it's actively developed by Oracle Labs in the glass tower. There's an official OpenJDK project for it, but most stuff happens on GitHub, so you can just go there, look at the PRs, or download the code. It uses JVM CI, as I said earlier, and it's written in Java. That's very important because Java has different properties than, let's say, C++. And C1 and C2 are written in C++. I have a talk, this one, how to use the new JVM JIT compiler in real life, where I explain the differences. So if you want to try Graal at some point in time, that you're not making mistakes when you do benchmarking, right? If you want to move to a new compiler or something like this, you kind of have to do some benchmarking and convince your boss, So I explain a lot in this talk, so you're not making mistakes if you're interested in that. Good. So these are the parameters I'm tuning. So I decided to tune inlining, and because inlining is the mother of all optimizations. Inlining enables a lot of other optimizations, especially when you inline better, escape analysis can work better. So these two combined, it's a huge win, especially for Scala services. And Twitter services, basically almost all of our services are written in Scala. So there is one called trivial inlining size, and it's 10. And 10 means nodes in the compiler graph. Okay, you parse a method, and then you have a graph in the compiler. And if it's less than 10, we inline it anyway. We don't look at profiling information or anything else because it's a trivial small method. We just inline it. Then there is maximum inline size, basically the other end of the spectrum. If it's bigger than 300, we don't inline it. And then there is one called small compiled low-level graph size. It's basically Graal and C2 as well. There are two intermediate representations. One is called high and low. Then it's like the low one is a little closer to actually native instructions. And so this is basically the same as the second one, kind-ish, but for the low-level graph. So also 300. If we have more than that, we don't do it. I have a talk, Twitter's Quest for Holy Grail Runtime, where I basically explain or tell the story of the first year of me working at Twitter. And in this talk, I show the performance improvements we're seeing by just moving from C2 to Graal. And when I did this talk, I did exactly what I said earlier no one should do. I hand-tuned it because I wanted to know if we could actually see some improvements, and I wanted to get a feel for it, what we tune, where does it go. You know, I just wanted to get a feel for it before I'm actually doing the auto-tune stuff. So this is GC cycles, scavenge cycles, parallel GC. And by just moving to Graal, we save about 4.2% on the tweet service in GC cycles. So we do 4% less GC cycles. And by hand tuning, I tuned the 3 parameters you just saw. I got 1.5% out of it, which is pretty good. I was sitting down a couple hours on a Friday afternoon, and this was the outcome. This was a little better. We can reduce CPU utilization by 13% for the tweet service by just moving to Graal without changing anything. Default Graal. It's amazing, 13%. I could squeeze out another 2. I was very proud of the 2, to be honest. You know, I'm not sure who's in compilers here, but getting 2% improvement is actually very hard. So, okay, don't do that manually. Stupid idea. This is the configuration, basically. It's like a JSON file, and then you see, you know, the parameters, the ones we are tuning, and as you also can see, I actually gave it ranges. You don't really have to do this. You could say 1 to 1,000, right? Because the Bayesian optimization would figure it out anyway. But I decided to do ranges because I wanted the experiment to finish in a certain amount of time for the slides so that I can show you better graphs. But when we run this, actually, we say 1 to 1,000 and just let the thing do it. Okay, so my test setup is one dedicated machine per instance. And this is very important when you do benchmarking, especially when you try to reduce user CPU time where, you know, 2% is basically in the noise. So you have to have dedicated machines where there's nothing else running on them. If I run the experiment in the data center, I barely can tell if it runs better or not. So you have to do this somewhere with dedicated machines. And then all instances receive the exact same requests, very important. Not the exact number of requests, the exact same request. Because a tweet, for the tweet service, for example, could be 1 character long or 280. And then the memory allocation would be very different. Good. We run with that version of JVM CI, Graal. It's a little older, doesn't matter. Default tiered, I explained to you what tiered compilation is. We run C1 and Graal. So we replace C2 in tiered compilation with Graal. That's all we do. Okay, experiment 1, tweet service. What's the tweet service? It's a Finagle thrift service. Finagle is a Scala framework, whatever, that we use to build our services. You can get it on GitHub. It's an extensible RPC system for the JVM used to construct high concurrency servers. No idea what it does. And I really don't have to know. But everyone's using this to build our services. The most important part is here the 92% in Scala. As I said earlier, Graal can optimize Scala code really well. And this one is basically entirely written in Scala. Good. Objective. What do you want to tune for? We want to tune for user CPU time. And we want to reduce user CPU time. And as you remember, Bayesian optimization looks for maxima. So we just take the inverse. That's really all. You just tell it that. And then we have a constraint. The constraint, I only did one constraint. It would be much better to have more. If we have this, for example, always on in production, we need certainly more constraints than just one. But in this particular case, for the slides, it was fine. As I said, we run in Mesos, and there's something called throttled. So if you're throttled, basically CPU throttled, then you're doing something wrong and you're really bad, and shit doesn't work. So here we go. This is the experiment, 24 hours. And as you can see, one evaluation is 30 minutes long. So I did 30-minute long evaluations, which is a little short. But for the tweet service and for the social graph service that you'll see later, 30 minutes is enough to get to a stable state and to actually see performance improvements. So I know that. That's why I did it that way. And I wanted it to be done in 24 hours, again, to get it on the slides. So this is one run. And this is the user CPU time. As you can see, the experiment is blue and orange is control. So every time the blue line is below the orange one, we see an improvement. If it's above, it's worse. And then when auto-tune's done, it's basically you get a web page and a table, and these are the results. I sorted by objective, and you see 1.0838, which means we reduced user CPU time by 8.4%, which is amazing. If you remember when I did it by hand, 2, 8. It's really good. With another 8, we have a 6.4, 6.4. So I would guess maybe we see a 6% improvement, right? Maybe the 8s are a little bit outliers or something. So we'll see that later. The bottom of the table looks like this. As you can see, 3 evaluation runs actually violated the constraint. So we tuned too far, and it didn't work anymore. Then there was one still running when I shut down the experiment, and that's about it. There's nothing else to say on this slide. You can also, as you can see up there, look at the charts of your evaluations. Take this with a little bit of grain of salt, because we are tuning 3 parameters. So I would have to show you a 3-dimensional chart, which is almost impossible. So every data point in here depends on 2 other values that are different, right? I would have to run the experiment 3 times with just changing one parameter to show you a good chart. But you know, you get kind of the idea. If you squint a little bit, you see it's actually going up a little bit the higher it gets. And then we have this one best example here. What is it, like 21, if I see correctly. So that's the result for the small inlining guy. And that was 10 default, as you remember. So it's double. This one, yeah, kind of all over the place, a little bit flat-ish. But as you see, there are 2 outliers over there. And the one is the best one. They might be outliers, or again, they depend on 2 other values, so they might actually be better. And then we have this one. You don't even have to squint to see what's going on, right? Default was 300 here, and we end up at 500, what's that, 50, 600, something like that. So certainly this one should be bigger for this particular service. And then what I did was I did a verification experiment. So I took the best result from the table, as you saw, and ran the tweet service for 24 hours. This is just requests per second, and it should be exactly the same as you said before, because that's what we want. And the tweet service uses parallel GC. So again, we look at scavenge cycles. You saw that before when I did it manually. And we can, in this run, it was 3.4% less GC cycles, which is nice. And then with the auto-tune, it looks like that. It's another 3.5, up to a total of, let's say, 7, which is pretty good. I mean, already moving to Graal was nice, but we were far away from the optima, right? We doubled it, basically. And that's what tuning can do for you. And the same graph, just differently, the same data, just in a different graph. It's allocated bytes per tweet. I'm showing you this so that you can see it's basically the allocated bytes per tweet is roughly the same over 24 hours, so it doesn't change a lot. And obvious, the result 3.45, 3.46-ish, 7-ish is the same, right? User CPU time, that's the one I care the most about, because user CPU time actually saves us money. Because if we can reduce user CPU time, one instance could handle more requests. And then we can shrink our instance size. And that means we need less machine, we need less electricity, we need less cooling in our data centers. I'm trying to save the world here. Okay, so as you can see, that's a lot. That's 12% just by moving from C2 to Graal. And then with the autotune, looks like that, it's another 6.2 to a total of 18%. We could reduce the tweet service instance size by 18%. We have thousands of these machines. That's a lot of money. I would like to get that money, but I don't get it, which is very annoying. So for the tweet service, I also looked at P99 latencies. I picked 99 and not more nines, because if you go more nines, it's basically the GC then defines your P numbers. But if you do 99, it's like still 99% of the time. That's most tweets. And you can see just by moving to Graal, there's certainly an improvement. It's a little hard to tell how much it is, but certainly an improvement. And this is the autotune one. Certainly also better, hard to tell. So what I did was I integrated over the whole 24 hours, basically summed it up, the whole pause times. And this is the result. So just by moving to Graal, we save 20% in P99 latency times. So they are 20% less. And then on top, 8% by the autotune stuff. So 28% better P99 times. That means you get your tweet 28% faster. You could technically then read 28% more tweets if you wanted to. Good. So social graph. I'm doing 2 experiments here because I wanted to show you how different applications can behave and what the performance tuning can do with 2 different ones. So social graph is also a finagle thrift service, so it's very similar to the tweet service. This one is an abstraction for managing many-to-many relationships, who follows who and stuff like that. That's what it does. Objective, pretty much the same, just the name is different. So we tune for user CPU time, constraint the same. We try to not get throttled. This is the run. 24 hours, different days, so the graph looks different. Again, 30-minute evaluation runs. This is the outcome. Certainly better sometimes. So let's look at the table. Looks like this. The top one is 7.6, and then 7.6 and 7.2. That's really nice. 7%, pretty good. Like it, 6.8, almost 7.2. So maybe we'll get 7. We'll see. If we look at the bottom of the table, there was 1 that violated the constraint and 3 were running. That's very odd. I don't understand why. So don't look at that. And then the charts look like this. Oop, sorry. It's not as obvious as earlier, but still, like it goes a little bit up if you squint. This one's all over the place. And this one is not as obvious as it was with the tweet service, but it's still the higher the value, the better it gets. This one, again, default 300, and I think our result is like 650 or something, or 649 or something like this. So with the social graph service, I think my range was a mistake, right? This probably should be more, because we're right at the edge. Good. Verification experiment, same thing. You've seen this before, requests per second. The social graph service uses CMS. So we are looking at par new cycles here. And the improvement here, moving to Graal, is, let's say, only 1.6 less GC cycles. It's just because the social graph service has different memory allocation patterns than the tweet service. But that's exactly why I want to show you this. It's just different code. Right? We couldn't eliminate as many object allocations as with the other one. But the interesting part here is we could reduce by tuning it much more than actually Graal could get out of it in the first place. So 5% is very nice to, what was it earlier, 7, I think. That's pretty good. Use of CPU time looks like that. It's also not as much. So we had 12 for the tweet service, and this is only 5.5. Tuning looks like that, and gets us another 7.8 up to a total of 13.3. The thing in this graph that I still don't understand, and I haven't had time yet to look into it, and it was not the case with the tweet services, if you remember, but with the auto-tune result, when the load is low, the improvement is not as much as when the load is high. So I picked a better number where it's high, obviously, because I want to look good. So that was the social graph service, 13%. That's really cool. Questions? Nope. 2 people. Let me guess your question. Is that your question? Well, of course I did, because I couldn't come up here and say, well, Graal is so cool, and then I didn't do it with C2, right? So I did the same thing with C2, tuned it, and I picked these 3 parameters. They're similar to what we tuned for Graal. So there's one called max inline level. Graal doesn't have that. It's basically how deep inlining goes, and it's only 9. So when you go 9 level steep, it stops inline, which is very interesting today when everyone's using 100 of different frameworks calling. You will never end up at what you actually want to inline. Then there's one called max inline size, which is pretty much the one we saw with Graal, and it has a default value of 35. The main difference here is the 35 here is bytecode size. Well, with Graal, it was nodes in the compiler graph, so very different. If you ever had code, and you added a bunch of assert statements to your code, to a small method, and then suddenly performance went to shit, it's because of that guy. Because when we look at bytecode size, the assert statements are counted, and C2 doesn't discount when it inlines it. Embarrassing, I know. We never fixed it. I'm sorry. Inline small code, 2000. That's a really odd thing that I don't understand why Hotspot has it. It's 2000 native code size. So remember when we talked about tier compilation? And it happens sometimes. This one is responsible if you do benchmark runs and you get very different results from run to run. It's probably that guy, because it's a race condition. When you have a hot method, it probably gets scheduled for a C1 compilation, but also there is a hot method that gets compiled in C2 and inlines the one method. If the C1 compilation comes first and it's bigger than 2,000 bytes, C2 will not inline it. But if the C2 compilation comes first, it will inline it. Don't ask me. I don't know. We should get rid of it, to be honest. All right, so these 3 I tuned. You've seen that before. It's just the names of the parameters. I tried from 5 to 20 because I wanted to see what happens if we go lower than 9. 10 to 50, and that one, what did I do? 500 to 4,000, I think. Yeah, okay, we tried that. All right, it's tweet service. We've seen that before. Experiment, 24 hours. Evaluation runs to 30 minutes. Same thing, didn't do anything else. Yeah, certainly a difference. So AutoTune is doing its job. Very nice. Let's look at the table. The result, the top result is 5.1. It's pretty good. I mean, you know, 5% by just tuning C2, which is around for a very long time, that's pretty nice. But we have a 5.1, a 3.8, a 3.5, 3.3. So I'm not sure if we actually would get 5. You know, when we remember the numbers we saw earlier, because when I do the verification experiment, it's actually running slightly differently than what AutoTune does in terms of the data it gets and things like that. So let's say, because I'm nice to C2, we get a 4% improvement. Well, yeah, I mean, that's pretty good. Bottom of the table, no constraints violated, very interesting. Nothing else to see here. Then graphs, you don't even have to squint what the fuck's going on here, right? Let me remind you, default is 9. So certainly 9, and I want to argue that 9 is even not the right value for every application out there. So this should certainly be higher. And it found 16 in that particular case. I think we could go to 17 or 18 or something like this. This one surprised me. Doesn't matter at all. But it's completely flat. I thought it might change something. Also, this one, also completely fit. Surprised me too. But, as I said, this is like a little bit of a racy thing, and so maybe it doesn't matter that much, especially for the tweet service. Okay, so I did not do a verification experiment for this guy, but as I said, AutoTune certainly did its job, right? Even for C2. I mean, we got a 4% improvement. That's nice. If I can get 4, I take 4, right? It's just the potential, the implementation of Graal, especially inlining, escape analysis. There's so much more potential with Graal to go forward and do more optimization on that front. And C2 is a very old compiler, and I really want to get rid of it because it's a pain in the neck. Okay, so summary. This is the summary I do for all of my talks. Very simple. That's all you need to do to turn on Graal. So Graal is in OpenJDK since 9-ish, but officially since 10, JDK 10. So it's certainly when you run on JDK 11, just have to turn on these parameters and you're running on Graal. And I'm sure you all run on JDK 11 in production, right? Yeah, exactly. Like Twitter does. No, we're not. We're running on 8, like everyone else. So, but I'm sure you have, and what day is today? Oh, today is not even Saturday. Tomorrow you'll go to work, I'm assuming. Just turn it on in production. Why not? Doesn't matter. No, you'll have some staging environment, right? You have to test your stuff before you push it out to production. Maybe try it there. Or you have some pet project that you're working on. Try it. The reason why I'm asking you to do this is, and it's also the reason why I'm doing all these talks, because Oracle Labs doesn't give me a cent for this shit. So the reason I want this, that I want you to try it, is we need to make it a better, mature compiler. It works really well for us. We run the tweet service, the social graph service, a bunch of other services, between 20 and 30 right now, on Graal for almost 2 years now, 100% in production. So everything you see on Twitter and do and tweet runs basically through code that's compiled by Graal for 2 years now. Have you lost any tweets? I did not. Works fine. We never had a single problem. We had some issues at the very beginning when we started using it, and this one talk, Twitter's Quest for Graal Runtime, I explained all the bugs we found. So if you're interested in that, watch it. But that was it. And then we never found a bug again. And, that's the issue. We need your shitty production code to run on Graal. Because these are the corner cases, right? We want to make it a more stable, mature compiler, so we need more code coverage. And Oracle Labs can only run spec PBB so many times, right? They're not going to find anything else. We have our stuff, but it's running fine, so we need other people to try it as well. And the main reason for this is I want 3 things to happen. One is, if you run something and it crashes, great. That's exactly what I want. Find a bug. Because if you find a bug, we don't find it. And if Twitter is down, my life is not that great. So, Dan, you could also potentially save money, like we do, right? So I'm really offering you free money here. Don't come up later and ask for it. I don't have it. And the third thing is, if you try something and it runs better, great. Let us know. Most people don't really report good results. They only complain and, bash on, the open source, So tweet it out maybe. Let us know that it works better. Would be cool. If it doesn't work better, like let's say performance is worse, it might be a little tricky, especially when it's production code in your company, because it's probably confidential IP, so you can't really give us access to it. But maybe you could extract a small test case and then file a bug, and then we look at it. That would be good. Because at some point, certainly me, we would like to replace C2 with Graal as the default compiler in OpenJDK. For good reasons, as you've seen. Right? I mean, for us, amazing. And this is, and I've hinted at this before, It's mostly because it's Scala code. So Scala is a highly, dynamic language, and so it allocates all these temporary objects, and blah, 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 functional programming style. And so the escape analysis that Graal does just works so much better with that. With Java code, it's like a 50-50 chance if it's better or not. We've seen services at Twitter that run way better on Graal, that are written in Java. Others run the same. Sometimes slower, rarely, but can happen. The reason for this is, and I've worked at Sun and Oracle for years on C2, we never, a single day or a single hour, we tuned Hotspot and C2 for any other language than Java. Never. So C2 is optimized for Java. But more importantly, the code you write is optimized for C2. Because you write it in a way so it runs the best on the existing compilers. So it's very, very difficult for a new compiler to come in and be better everywhere, right? So try it. Let us know how it works. Again, I've seen stuff run faster. I've seen stuff run slower. Most of the time, runs the same, which would also be a win. If it runs the same performance for you, you don't really care what you're running on, right? But for us, it would be important, because then we can do more optimizations. My colleague Flavio, I mentioned it at the beginning, he's working on some Scala-specific optimizations in Graal. We get ridiculous performance improvements. I cannot even believe it. Like every time he shows me numbers, I can't believe this. But there's so much potential in Graal that I really would like this to happen. And also, for you, and, remember the saving the world part. Good. That was everything I had. Tweet about this event. Tweet about my talk, maybe, if you liked it. Don't tweet if you don't like it. Thank you very much. Questions? Like real questions this time, not like earlier.
Thanks a lot. It was really great talk. When looking at the tables with the best result from AutoTune, if you look at the actual values of the parameters, they were sometimes all over the place. So there was no kind of linear correlation or something like that.
Right.
Did you also plot them against each other to see if there's any correlation between them? Because it felt a little bit random.
It feels random. I totally agree with you. Yes, we have not looked at any correlation at this point in time. No, but I absolutely agree with you. It's all over the place, which I'm assuming. I'm really just guessing, but different values, you inline different stuff. So, you inline this stuff over here, and then it's faster, and you inline this stuff over here, and it's about the same performance, also faster. So, I think it's fine. It doesn't really matter. I don't think you could make it so that everything gets inline and it's twice as fast. Because then we hit some other issues with like code cache size, and yeah, you know what I mean. So. Let's put it this way: if we would already be there where we want to be, where this is in production all the time, I don't care. It can be all over the place, as long as it's faster.
So right now, is this something you run as a part of a release, or how often how would the code change actually change the situation, or is it just that you say these services are pretty stable and not change all the time? That's why you just can do it on a production like code base and do these tests.
Right. So usually people ask me, "Oh, is this open source?" Right? It's not at this point in time. We wanted to make it open source. It's really unusable at this point in time. The JSON file you saw, I have to curl it to a URL. And if I want to shut down my experiment, I can only shut down all of them. So it's like unusable at this point in time. And we don't use it in production, as I said. We want to get there. The only thing we do, and we've done that once and then we haven't really done it again, is the tweet service, the results I got, they're actually running in production. But that's the only service where we've really done it, because again, it's the same thing. You tune it once and then you leave it, but at least it was a machine doing it. So no, we're not there yet. Other questions? Yes.
So one question, how did you choose the size of the message you optimized for?
The size of the...
size of the tweet. Because
the size of the tweet. I didn't choose it. So the way this works is it's dark traffic. So basically it's production traffic that's actually people are tweeting over 24 hours, and my instances get a share of that. It's real world data. I didn't pick anything. It's nothing, not a replay or anything. It's like real world data.
Did you also use AutoTune for other things, like, I don't know, database optimizations, other costing of things and stuff like that?
You could. Yeah, absolutely. You could.
You didn't do it at Twitter in like other scenarios
so
or other things? Or your colleague?
Right. So the AutoTune project is already a few years old. It was on ice for a while, and now we survived it. The initial idea was to actually tune GC parameters. So there's a talk somewhere, it might have been one of the ones that Ramke that I showed earlier, where they actually showed a performance improvement when they tuned the heap. But I don't care about the GC, I don't care about the compiler. Yeah, but you could. Even non-JVM stuff, you could. Sure, could be anything. All right, one last question up there. Way up.
So how long is your measurement typically for one parameter when you want to get the number? And then how can you reduce this? Have you thought about that?
So in all the experiments I did, I was running for 24 hours and I only did 30-minute evaluations. I said this. So that's pretty much everything I do. When we get to the point where we actually have this always on, we have to think, how long is an experiment, right? I mean, yes, we deploy code multiple times a week, but it's not changing dramatically every time. And so we are thinking, maybe an experiment is a month. Could be, right? You run your evaluations, I don't know, a couple hours or maybe even a day. I think it would be fine. The code doesn't change so much all the time, but you certainly should be tuning all the time.
And have you tried doing parameters per function in your code? Not by the whole code base, but just per particular hot function?
No. And the reason is, well, there are two reasons. You can't do this in Graal, really. There's no machinery to do that. And it would be way too much.
Cool. Thanks.
Yeah. Cool. All right. Thank you very much. If you have more questions, you can come to me.